are finishing up the second week, and I don't know about you, it feels like we just started. I was thinking about that at about 4 a.m. this morning and thinking, hey, I feel like I'm just really getting going here, and it's over. So I'm sure you're lamenting that and just sad that it's a Thursday. Yeah, just tears of sorrow, right? No sincerity. And I'm being as unrighteous and cynical as I could be at the moment. The work we did for today involved division. And I'm going to talk about one of the questions that came up in the last hour that I think I want to address, because you probably are in some ways doing much of what I did as a student when I was here, and I attended here also. As a student, I always did homework, but I never read the book. The assignment was there. I do the homework problems, and I never thought to read the book. And I think the first real change in behavior that I had to go through as a student was spending time reading a textbook to see what the authors were saying, because it was the way I survived. Now, as a major, I was an engineering major, so I had, at that time, courses in chemistry, physics, mathematics, English, history, and you just had to read or you didn't make it. The other thing I learned in doing that, and I've never really been able to locate where this was, but there were a lot of students here who were older than I was at the time, and they created study groups. And we would meet at midnight and study until 3 in the morning or something. We didn't sleep much. But study groups really worked because we got together and we had a whole lot of homework we had to do, and we spent time doing it. And I really encourage you. I think that's the way to survive. But going back to reading a textbook, there was in my presentation a statement on page 41. That was a rather important statement. Here's what it states. It says division. I'm in the middle of the page. Division can be thought of as a repeated subtraction. For example, dividing 12 by 3, and that's where I'm referencing, dividing 12 by 3, that's where I'm pointing now, can be found by asking a question. How many times can 3 be subtracted from 12? And so I show the result. A total of 4 times, so that's how we get our answer. Now, there's another statement I made to you yesterday that didn't seem to get picked up by everybody. If I tell you 3 times 4 is 12, that's a multiplication. What is related to that multiplication problem if I tell you 3 times 4 equals 12? There are 2 division problems you learn. 12 divided by 4 is 3. 12 divided by 3 is 4. All from that multiplication. Now, those 2 pieces of information had everything to do with the 5th review test you were supposed to have done for me today. The question, number 4, asks you, okay, there it is. How many times can 235 be subtracted from 17,390? And you did not sit there and subtract. Now, if you subtracted for a few hours last night, you missed the point of that first opening page, which said, divide. Okay? But you had to guess the answer to multiply. You just kept multiplying numbers until you got there. Oh boy. Okay, that's not bad. I mean, that's not bad. That's clever. I'll have to make the problem harder, so that's not so easily done. Okay. Now, the next one. This is number 5. This is what we were talking about yesterday. I'm giving you the product. The product is 7,967. Now, that's a pretty big product. And I'm telling you one of the numbers is 31 that you multiplied. What's the other number that was part of the multiplication? Well, you had to divide or guess well. Now, it may be possible to guess well and get that answer. Okay, coming off there. But generally speaking, it works better to do what? Some division. Then, somebody asked me on this problem, and I thought, well, more power to you. They asked, were we expected to do number 3a with short division? What's your answer to that question? No. When do you use short division? When the divisor, the number outside, is what? 1 digit. Maybe 2 at most. But 3-digit divisors and doing short division in your head, I think you'd find yourself hard-pressed. I don't do that. Okay? I've done a few, but it's more just to see if I can climb the mountain, and I suffer. But it's not something I'd expect you to do, and certainly not sitting there with a glass of good wine, fireplace going, music going, and you're going to do short division with 3-digit divisor. You're sick. Okay, so you have to know when to do short division, when not to. So that was all part of what was going on. And my point, I think it helps to read. Spend some time reading what I wrote. See if it helps you. The intent was to write it so it would help you. Well, what fun do we have today? Now, I'm going to give you a warning right now. This assignment could take you over 3 hours to do. So don't wait until Sunday night, 11 o'clock at night, and say, I'm going to get this done in the next 30 minutes. Not going to happen. We're in Lesson 6. Inner computational review. Now, typically on a Thursday, what would I be doing? Typical Thursday. In the Orange Book, Vitamin C Day. However, we had a short week. We have Monday off. So, can't really do that. Here's today's delight. Special for today. Prime numbers and factoring. Okay. Now, where there are 18 reviews in this book, I'd say this may be the toughest of the 18. So I'm glad it's occurring on a weekend. That gives you 3 days, an hour a day minimum on this, and you might get through it. Now, I'm going to have to caution you about something here, because we've been playing music, and there's a song from Kenny Rogers, who's still very active in singing, just released an album. And what's the song? Any of you think of the song that goes with Kenny Rogers, probably because he became movies in the process, TV movies and so on? The Gambler. You got to know what? You got to know when to hold them and when to fold them. You have to decide when you should stop dividing, or you will divide all night. That's the message. Think of Kenny Rogers. Know when to hold them, know when to fold them. And I'm going to give you the answer for that. Now, first, we need to talk about primes. We've talked about them already. And I'm going to introduce you to an idea that was first presented by a Greek mathematician named Eratosthenes a long, long time ago. It's called a sieve. And you understand what a sieve is? A tennis racket can be used to drain spaghetti. Don't recommend it for the tennis racket. Got boiling water, noodles in it. Pour the spaghetti with the water onto the tennis racket. The water goes through and leaves you what? The noodles, the spaghetti. Some of it may go through. If you don't have a tennis racket, what can you use? A colander. You can go down and actually buy something out of metal or glass that will allow the water to go through and keep all the noodles. Okay? A sieve. Now what we're going to do is put all the numbers we have through this sieve, and what is left will be the primes. Now, to save doing what I had on the board, because I found that I didn't have as much time as I needed really to do everything I wanted to do this morning, I have listed from 1 through 40 the numbers in a very interesting way. I started with the row 1 through 10, 11 through 20, then 21 through 30, 31 through 40. Will you write that list down for me on paper? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Next row, 11, 12. Don't cross anything out. Don't circle anything. Just write the numbers. Up through 40. Has to be in a row, not a column. You want rows, not columns. Rows. So you're going to write the numbers up through 40. What the heck? Go through 50. Add another row in. Okay, Debbie, go to that other shot where we have everything there, and I'm just going to walk off camera for a moment. So remember, we have these, you'll have 5 rows. 1 through 10 in the first, 11 through 20 in the second, 21 through 30, 31 through 40, 41 through 50. And then I'm going to have you do what I did to get the primes. So have you got your list now? Up through 50. Now what we're going to have at the end are the primes under 50. That's the payoff. Now what happens if I wanted the primes under 100? What would I have you do? Go all the way up to 100, right? If I want the primes under 1,000, how far do I have to write? Up to 1,000, okay? Here we go. I want you to cross out the 1. Just put a little line through the 1. Circle your 2, and then you're going to do the following. You've circled your 2. Then you're going to count after the 2. 1, 2, cross out. So you're going to cross out the 4. Then 1, 2, cross out the 6. 1, 2, cross out the 8. Got it? Do that all the way through. So you circle the 2, then you count after the 2. 1, 2, cross out. 1, 2, cross out. 1, 2, cross out. Has a rhythm to it. The sound of numbers. All the way through to hit 50. Go quickly. Okay, some of you are done. Most of you seem to be done. You're getting there. What did you just cross out? All the even numbers, correct? You crossed out all the multiples of 2. Multiples of 2. You crossed them out. Are we ready for the next one? The 3. I want you to circle the 3, and then you do the following. 1, 2, 3. That's where the 6 is. You cross it, but you already did. Cross it again. Then 1, 2, 3, and suddenly the 9 goes out. Finish out the list with 3s. Waiting for you to finish up here. You're crossing out every third one after the 3. So what have you crossed out? Multiples of 3. Okay, next. Next prime. 5. Circle the 5. And count. 1, 2, 3, 4, 5. So the 10 gets lined through. 1, 2, 3, 4, 5. The 15 gets lined through. And so on. Keep it going. You're crossing out multiples of 5. One more to do. I want you to circle the 7 this time. And count what? 7. So you go along, you circle the 7, and you go 1, 2, 3, 4, 5, 6, 7. When you hit the 14, it's already out. And you just do that to the end. Okay? When you're done, I want to talk to you about it. The last number you cross out is that 49, right? Circle everything that's left. The last number you should have crossed out was the 49. Circle everything that's left. Okay, I'm going to write some numbers up here that I didn't have before. And of course, what you found, that all these numbers were crossed out, and you then had 41 left, you had 43 left, you had 47 left. Agreed? Now check against what I have up there. Do you agree? Do we agree? Nod your head up and down if you agree. I've got 2 people up and down, 3 people, 4 people, 5 people. Keep going. 6, 7. Only 7? Come on, we can do better than that. That's not exactly a winning feeling if I only have 7 of you who are in agreement. Let's try again. Nod your head if you have it. Okay, got a few more nods up and down. Don't do it too much because you'll go to sleep, but the idea was, okay. The numbers you have left are the primes. And you only had to go up to 7, but you got the primes all the way up to what? 47, under 50. Okay. Now, if I'd gone to 100, what's the last prime you'd have to circle and count? 11. Just one more, and it would have given you everything up to 100. The key is as follows, and it's the secret to a shorter work week on the weekend. Here we go. I'm going to go to the side here, and I'm going to show you this statement. Using the sieve, now we only went to 7, right? 7 squared was 49. So when I stopped at 40, I didn't need to use 7. But when I stopped at 50, I did have to use 7. So when we did it to 40, okay, up to 40 and stop. That's what I originally had up here. Remember, I stopped this one. I asked you to go to 50. But when I stopped at 40, I didn't have to go past 5 because my next prime squared was larger than my last number. Now, I do have to do 7 if I'm going to go up to 50, right here, because 7 squared is 49, and that's smaller than 50. But I don't have to do 11 because 11 squared is what? Greater than 50. It's also greater than 100. So what you did up through 7 would have worked all the way through 100, and your last prime, I'll tell you what it is. It's 97, under 100. It's not the last prime. They never end. So you have to know when to stop. With the sieve, you didn't need to go past 7. And you get all those primes free. Now, you may think that I'm keeping information from you, that there's some magical way of finding primes. There is not. The sieve of Eratosthenes is probably the best method, if you don't mind writing all the numbers down, that I can give you for finding primes. If you aren't going to use the sieve, then you have to start doing long divisions. And I'm going to illustrate a problem that I did today in the last hour to see if a number was prime or not. I just want to illustrate it, and then we'll try a different one. Now, think of a year. This year is 2006. What number will divide 2006? You're guaranteed. 2, because it's even, correct? 2 will go into 2006. So 2006 is not prime. If a number is prime, what are the only numbers that you can divide? 1 and the number itself. So 2006 is not prime. It's divisible by 2 because it ends in an even number. Okay, what about 2005? 2005 ends in a 5, so it's divisible by 5. We talked about that yesterday. Pardon? Well, we aren't at 2007 yet, so I'm just taking the years we've been through. Next year I'll talk about 2007. Maybe it's an interesting number. No, 2007 is not interesting. Why? We already know that. Why is 2007 not prime? What's my divisibility rule for 3? Add the digits. See if you can divide the sum of the digits by 3. Okay, 2007. What's 2 and 7? 9. 3 will go into 9. 3 will go into my number. 2007, I don't really care about 2007. Not prime. What about 2004? What number? Guaranteed, 2004. A 2 because it ends in an even number. So that brought up 2003. Okay, let's look at the board. Here was the number we did the last hour. And I just stumbled into 2003. I was thinking of the years. I didn't think of 2007. I started with 2006, and I wanted an interesting number. Now, I said 2003 was interesting because I can't divide it by 2. Why? It ends in an odd number, so 2 won't go into it. What about my rule for 3? Add 2 and 0 and 0 and 3, and what do you get? 5. Will 3 go into 5 with no remainder? No. Therefore, 3 won't go into this number evenly. Will 5 go into it? No, because it has to end in a 5 or a 0 to be divided evenly by 5. So I've got to check all these primes. How far do I have to go before I can say fold? Well, I look for the largest prime that has a perfect square more than this number. Now, these are the primes you got in your list, right? 47 was the last prime in your list. You just got that out of the sieve. Anything at 50 or higher isn't worth looking at it, because what's 50 times 50? Good, wrong answer.
Oh, yeah.
You're adding. Okay, 25,000 because it's 50 times 50 means a 5 times a 5, not 25,000, 2,500. I got too high. 2,500. And 2,500 is bigger than this number. So anything at 50 or more, not interested in. So I didn't really need to even consider 53. What about 47? Let's look at 47, and I've got that written up here for you. 47 times 47. I'll just rotate out here. You have 47 times 47. Now I did 7 times 7 and got 49. Carried a 4. 7 times 4 is 28, plus that 4 is 32. Now if I'm blocking your view, the monitors are back there you can look at to make it so it's easy to see. Then I did 4 times 47. Remember, I moved 1 over. And 4 times 7 is 28. I carried the 2, got 18, and I added 9, then 10, carry the 1, that gave me 12, carry a 1, and I get 2,209. Too much. I don't need that much. So 47's out. Now I was concerned, is 43 squared bigger than my number? So that's what I did here. And just following it through, you see you get a 1849. So 43 I have to check. So here's what I end up doing. I take this 2003 and I have to divide by every prime in this list until I get down to what? 43. Now, if none of those numbers will go into 2003 evenly, 2003 is prime. Okay. Just as a way of doing this, since Debbie, I guess you have to be in camera 1 or you've got magic going. I'm just going to walk off camera, leave this here, and I'm going to go over to the sideboard and show you the fun we had in the last hour. Okay. We started dividing, and you can see in a moment on camera if you don't like turning your head that far. Okay, first thing I did was start dividing by 7. And notice what happened, and we'll just sort of go through this, and then we'll do our own problem. 2003. And I started with the 7, and look what I got. A remainder of 1. So 7 wouldn't do it. I did 11 and got a remainder of 1. It has to go evenly. So 7 and 11 are out. Then I went to 13. It didn't work. Got a remainder of 1. 17 didn't work, got a remainder of 14. 19 didn't work, 23 didn't work, 29 didn't work, 31 didn't work, 37 didn't work, 41 didn't work, 43 didn't work. Therefore what? 2003 is prime. It was a very good year. We should be doing Sinatra. It was a very good year. 2003. It was prime. Well, we don't want to do 2003 because it's been done. And a suggestion was made 2007. So maybe we'll just take 2007. I have no idea where this will take us, but we'll have some fun. So we have to do a lot of divisions. How far do I have to go? All the way up to 43, just like before. So I'll walk with Debbie as we go back here. I walked away from Debbie. Sorry. So let me just erase. Pardon? Yeah, but maybe we're lucky. Are we lucky? Why did we say we're lucky already? What was the argument with 2007? Why do we know we're in luck? It's divisible by 3. You couldn't ask for a nicer gift. It can't be divided by 2, but we know it can be divided by 3. And that will make the number I have to deal with smaller. Okay, let's divide by 3. You don't seem nearly as enthusiastic about this as I'm feeling. I mean, you have this sort of like you've been abused in some way with numbers. Okay, 3 into 20. 3 into 20. 6 times 5 would give you a remainder of 5. That would be too large, so let's try 6. It's an 18. Short division. I'll bring the 2 up. Ouch. Bring the 2 up instead of bringing the 0 down. 3 into 20 again. 6. 18. Bring the 2 up. And a 9. Folks, we have managed to escape the dungeon. Let's go to the front board again, Debbie. Now let's look. I said at the beginning I'd have to go all the way up to what? 43. Time to look at a shortcut I gave you this week. In between 23 and 29 is a very nice number for me. The number I'm thinking about? 25. What was the shortcut I gave you for squaring a number ending in 5? Do you remember it? Oh, not good.
It always ends in 25.
It ends in a 25. That's good. And how do I get the number before the 25? Multiply what? Good. 2 times what? Times the next number. 2, and the next number is 3, and 2 times 3? Let's go through that one more. We did it before, and obviously we didn't keep it. I want to square 25. I know the last 2 digits will always be a 25 if it ends in a 5. How do I get the digits before the 25? Take whatever came before the 5 and do what? Multiply it times the next number. So the number after 2 is 3, and 2 times 3 is 6. There's my number. Why is that important? Well, look at the number I had. It was 669. This number is nearly that big, and if I square 29, I'll be close to 800. So this gives me a way of knowing that the last number I have to check this time is 23. We already have done the 3, so we just have what? Just up here, we've cut half our list off. That's good. Okay, Debbie, back to the other. I'm not selling this well. Will 5 work? Will 3 work? I should finish up 3s. My apologies. Okay, I have 669. Will 3 work again?
Yes.
Yes.
Explain. Defend.
Well, 3 goes into all 3 of those numbers.
It's not enough. It worked. I mean, it's a good argument, but I want a better argument. What's my rule for dividing by 3? Okay, add the digits, right? And if the answer when I add the digits can be divided by 3, my number can be divided by 3. So what are my sum? What is the sum going to be? 6 and 6 is 12. Add 9, 21. Will 3 go into 21? Yes. So will 3 go into my number? Yes. Okay, let me start this a little different way. I'm going to put it down here so that I can keep doing my divisions. This is the way I would like to see them as you do them. So I have my 669, and then I'm going to do what again? Divide by the 3 one more time. Okay, come on. Divide by 3 again. So let's see what we get. You just have a seat over there. Okay. Now, 3 into 6 goes? 2. 3 into 6? 2. 3 into 9? That was sort of nice, right? Now we're down to what number? 223. Debbie, back to the front. Okay, now let's see what we've got. Do I still have to go as far? Do I know when I can quit? Any response? What's the next number I'd like to consider? $15 squared. Okay, time for the shortcut. What's 15 times 15? It ends in a 2.5. And then what? 1 times the next number is 2. So 15 squared is 225. That's bigger than what? Back to the side. 223. So anything at 15 or higher would be too much. 17 would be too much. So when do I get to stop? At 13. And I'm already what? At 3. I don't have very much more to check. Life's gotten better. Okay, I'm still hunting for some kind of enthusiasm here, and it's just not there yet. Let's go back to the side. So what's the next number I'm going to try again? I try 3s until they won't work anymore. Agreed? So if I try 3s until they won't work anymore, I'm going to pass this roll sheet back so it can be signed. So I'm going to come here to this. Will 3 work again? Pass it back to the very back. Will 3 work here? Give me an argument. I heard a no. I want the argument. Okay, 2 and 2 is 4. Add 3, you get 7. Will 3 go into 7 evenly? No, we're done with 3s. So we go to 5s. There's my list, my 5. No, I have to go up to 13. Will 5 go into 223? I only heard 1 no, and that's it. Why? It doesn't end in a 5 or a 0. So 5's gone. Next number on my list, Debbie? 7. Will 7 go into this? Well, let's try it. Don't look very promising because 7 into 22 goes 3. That would leave what? A 1 as a leftover, and 7 won't go into 13. So 7 is a no. Back to my list. I only have 2 more numbers to check, right? And then I can fold at that point and go to the next problem I want to do. So after 7 came 11. Just remember your favorite store for snacks at midnight. Your 7-Eleven. Okay, we're going to try 11. Will 11 go into 22? Oh, yeah. No remainder. Will 11 go into 3? No. 11's out. Well, that puts me at the last one. 13. Okay, if this doesn't work, what do I know about 223? It's prime, and I'm done. Okay, 13 into 22. One time. What's left? A 9? Agreed? That makes a 93. Now, 7 times 13 is 91, but that would leave me a remainder of 2. I am done. 223 is prime. So I'll just divide by it. I get a 1 up here. And so what is my product? It is. How many 3's did I have? 2 of them. So 3 to the second times 2, 3 to the first. That is my number. 2007, written as a product of primes using exponents. What you see in the board is what I want to see in your paper for homework, for the exercise, and for the review test. Okay? Any questions on that one? Okay, I'm going to go to the year that bothered a lot of people, 2000. Now, it bothered people, why? What was the big flap about 2000?
The computers and the binary.
Yeah, the problem was the computers. In all the computers written, programs written back in the 80s and the 90s, we had 2 digits for the year. So if you had a 95, that meant 1995. So if you had a 00, it meant 1900. And it was supposed to be the year 2000. So we had some big concerns. There were a lot of reactions to that. But let's look at the year 2000. Debbie, I'm going to slide over now as we're just going to come back. I'm going to get rid of this information here as we do that. So give me some space to do another number in a moment. But here was the year 2000. Now I'll just show you what I did. I listed my primes, 2, 3, 5, 7, 11, and I could have gone further. I wasn't too worried at the beginning because 2000 ended in a 0. So I knew it could be divided by what? 5 or a 2. So basically I could divide by 10, and that would leave me 200. So I thought, well, let me just list the first few primes. I don't have to panic yet. So let's see what happens in that process. In the process, when I divided 2 into 2000, I immediately got 1000. Divided by 2, I got to 500. And dividing by 2 again to 250. And divide by 250, I got to 125. Okay, and I knew that ended in a 5. So I could divide by 5. We got a quarter. Divided by 5 again. And I ended up with these numbers. Went very fast compared to the last one, which took a long time. So how many 2's did I have? 4 2's. So 2 to the 4th. How many 5's? 1, 2, 3, 5 to the 3rd. And I've written 2000 as 2 to the 4th, 5 to the 3rd. Now the argument is to be able to write a number that's not prime as a product of primes. And I'm using exponents. So let's do another number. Let's see if we can get something that's interesting, like 2000. Anybody have a suggestion? 1988. Okay, we'll try that. So I'm going to slide over, Debbie, back to here, 1988. Now, am I worried about 1998 being a prime? The answer is no. Why? You said 98, right? Or 88? 88. Doesn't matter. It's still, I'm not worried because why? The last digit is even. So it can be divided by 2, and immediately I'm going to be down to something under 1,000. So I take a number that's nearly 2,000 and get it very workable. So again, I'm going to list my primes: 2, 3, 5, 7, 11, 13, 17, and I usually don't go much beyond 17 when I'm starting out, unless I realize I may be in trouble. Now I'm going to do my divisions, and I'm going to do them stacking them. So 1988, I keep wanting to say 98. Okay, I'm going to divide by 2. Remember, it's short divisions. Are we ready? 2 into 19. 9, what's left over? 1, and again, watch the monitors if I'm in your way. 2 into 18. 9, no remainder. 2 into 8. 4. Do I feel good still? And if so, why? It ends in a 4, and so what? Divisible by 2. So that means this is getting better quickly. Okay, let's try again. 2 into 9. 4 times, left over. 1, 2 into 19. 9, left over. 1, and 2 into 14. Oh, that 7 means no more 2's. Right? I'm done with the 2. So I'm going to cross out that 2. And the key here is don't jump around. Okay? Because if I jump around, I won't know when to stop. Back to that song, know when to hold them, know when to fold them. So we aren't folding yet. I don't know about 497. What am I going to do next? I'm going to add the digits because I want to know if 3 works. Okay, 4 plus 9, 13 plus 7 is 20. Will 3 go into 20 evenly? No. I'm done with the 3. Can I wipe out the 5 quickly?
Yeah.
Give me an argument. I heard a yes.
0, 5.
Doesn't. This number doesn't end in a 0 or a 5, so I'm out of there. Now, I might want to, at this point, look at my list, see how far to go. But if I'm awake and alert and feeling good, doesn't 497 look good to you? Some of you it does. If it doesn't, you need more energy. You need coffee. Because let's try 7. What's 7 into 49? 7, no remainder. 7 into 7. 7 into 7. 1. 71's good, because if 71 is the answer, do I even need to worry about checking 11? No. Why? 11 squared is 121. It's bigger than this number, so I don't need to check anything from 11 down. The only number I need to check is 7, and so I ask, will 7 go into 71? No. So that means 71 is prime. That's a neat problem. I'll have to remember that one. How many 2's do I have? 2 of them, so 2 to the second. 7 to the first. I only have 1 7. And 71 to the first. Neat problem. I like that one. Now, the argument. Just because a number's big doesn't necessarily mean that you're going to be in trouble. 2000 was big, went nicely. 1988, big, but not in trouble. Okay? Is there any question what I just did there? Because what you see right here is what I want to see on your homework problems. And Debbie, as we slide over again, just to pick up the next one, again, this is what I want to see on your homework problems. Okay? I'm going to leave that on the screen momentarily, and I'm going to back off the screen, and then I'm going to go back to the document cam, because I want to look at your exercise. I want you to understand what I'm asking you to do. And just because the numbers are big doesn't mean that you have to panic. But I warn you, you could find yourself not stopping soon enough if you don't follow what we did. The key, do things in a very organized way. You start with 2, go to 3, go to 5, don't jump around. Otherwise, you will not know when you can stop. I'm on page 57. A 72 and a 420. Now, both of those are even, correct? Yes. So you know they aren't prime. Okay, let's go down to the next group. 500 and 675. Both can be divided by what? 5. So you know they're not prime. Next, 336, 910. Both are divisible by 2. They aren't prime. So you know you immediately get something to work. Going to page 58, your first two. 840 and 375, what can they both be divided by? 5. I have never realized until this moment that pairing them up this way, the same rule works so far. Let's see if it works in my last two. Ah, rats. Okay, didn't. I have 1728. It can be divided by what? 2. What about the 1311? Can't be divided by 2, but what do you see? Add the digits. 6. 3 will go into 6, so 3 will go into that number. So every one of these is non-prime. Now, non-primes are called composites. And what we're saying is that you can take any composite and write it as a product of primes. We're going to the review test. It's page 193. By the way, is 193 divisible by anything that you note immediately?
3.
Yes, 193 can be divided by 3 or not. You said 3. I nearly bought into it. 193. Add the digits and you get what? 13. Yeah, I nearly got that one too. Okay, so we didn't do well in that one. I didn't, at least. Let's go to review test 6. We have a 60 and a 468. Are either of them prime?
No.
No, because they can be divided by, well, 2 in particular. They're both even. Okay, coming off there just a minute, I'm going to try to get that down a little bit tighter to help the reading. Okay, 75 and 1,350 can both be divided by 5. Not prime. Next one, as a pair. 192, 2340. They're both even, can be divided by 2, so they're going to get better. Continuing. 171 and 6670. The 6670 can be divided by 5 or 2. What about the 171? Divide by 3, because 1, 7, and 1 is 9, and 3 will go into 9. Okay? Continuing. One more group. Debbie waited for me, and I didn't get the hint. Okay, I have 360 and 12435. 5 works, correct? So, that's not a problem. However, I've got a challenge I've got to see if I can do in a minute. 193. Okay, 2 won't work, 3 won't work, 5 won't work. How far do I have to check? Remember my primes, 2, 3, 5, 7, 11. Do I have to go past 11? Well, 13 squared is 169. I'd have to go that far. This didn't work, this didn't work, this didn't work. And I think these are the only 3 I have to check. 7 goes into this twice, but gives me a 53. It won't work. 11 goes into this once, leaving an 8. That won't work. So it looks like the only one I have to worry about is what? 13. Will 13 go into that? So I take my 13 into my 193. It goes one time. I have 6 left over. That doesn't work, so it looks like this may be what? Prime is my first reaction. So we'll stop at that. You have a homework assignment. Review test number 6, the exercise number 6, and here's the last announcement. A quiz on Monday on the first 6 lessons. These 6 lessons must be finished up so that I can check your book while you're taking the quiz.